Welcome to BC Video 12.2 Part 2, Integration of Vector Valued Functions.
Integrations, if we can differentiate, we can integrate. So if r of t equals f of t, comma g of t, if I think of that in component form, and f and g are continuous on the interval from a to b, then the indefinite integral antiderivative of vector value function r is the integral of f of t dt I plus the integral of g of t dt j. So basically what they're telling you is if you want to take the derivative, just take the derivative of the coefficient of your unit vector I, and then don't forget, take the integral of your unit vector I, and don't forget to then stick the I on top on that, and then plus, and then the integral of g of t dt times j. And if it's definite integral, then you'll just have limits of integration. So that's pretty straightforward. Okay. Now, there's a little bit of a tricky thing here. If you pretend that the integral of little f of x, which is a real valued function evaluated at real numbers, is equal to big F of x, which is another real valued function, plus c, which is an arbitrary constant, right? That's the normal thing that we do. What's going to happen here is that in each case, you have the integral of r of t dt is the integral of f of t dt times I plus the integral of g of t dt times j. Well, each one of these integrals is going to give some integral, a big F of t plus c1, and that's a real number. Same thing over here, you'll get some function g of t plus c2. Well, if you think about it, since we're multiplying all this by I, if I distribute, I get the following. If I distribute this, I get the following. But if you take c1i and add to it c2j, what you really have is another vector. It's like a constant vector. Therefore, what we can do and what's easier to do is instead of having these individual little c's, you could just bunch them together and say plus an arbitrary vector c. The key thing is you have got to make sure you have a vector symbol on here. This is not plus c, the real number c. This is plus the vector c. 53 to 60, find the indefinite integral. So very simply, you just split it up. You take the integral of 4t cubed dt times I plus the integral of 6t dt times j. When you integrate 4t cubed, you get 4t to the fourth over 4 times I. Over here, you get 6 times t squared over 2 times t plus an arbitrary vector c. Remember, it has to be a vector c. This will give us t to the fourth I minus 3t squared j plus c. If it's in component form, then this c is actually c1 comma c2, and you'll get t4 plus c1, 3t squared plus c2. Evaluate the definite integral. So for example, the integral from -1 to 1 of ti plus t cubed j dt. Now I'm writing, t equals to t equals, but you know that it has to be in terms of t because of the dt. So you're going to integrate an integral from -1 to 1 t dt and leave the I on the outside. Same thing, leave the j on the outside. That'll give t squared over 2 evaluated from -1. This will give t to the fourth over 4 evaluated from -1 to 1. And when you plug that in, you'll get 0i plus 0j, which is this 0 vector. Be careful you don't write the number 0, it's the vector 0. 69 to 72, you're given r prime of t, or maybe the second derivative of r of t, and you're asked to find r of t for some given conditions, which are initial, with some initial conditions values. So for example, 68, they're telling you that r of 0 is 1i plus 2j, and r prime of t is 0i plus 3t squared j. The question is to find the function, vector value function r of t. So obviously if I'm going from r prime to r, I'm integrating. So I integrate 0 dt times I integrate 3t squared dt times j. This will give me 0t plus c1 times I. This will give me 3t cubed over 3, which is t cubed plus c2 times j. All right, writing it then in component form, Now what we can do is we can take that initial condition. R of 0 is 1i plus 2j. So what we're going to do is, why am I replacing? Oh, because R of 0 is equal to 1i plus 2j. So I'm going to replace the t by 0, and that'll give me 1i plus 2j, which in component form is 1, 2. Therefore, 1 is equal to c, and 2 is equal to 0 cubed plus c2. So c1 is 1, and c2 is 2. So I go back, and I can rewrite c1 as 1, t cubed plus, and then c2 is 2. And then if you wanted to, you could go back into a linear combination mode, which is 1i plus t cubed plus 2j. Number 70, you're given two initial conditions, and r prime of t equals 0i minus 4 cosine tj. So if the second derivative is equal to this, to get to the first derivative, the question, I believe, is find r of t. Find r of t for the given. Let me actually capture that for you. So 67 to 72. I don't think that worked. I don't think that worked, but we shall now find, oh, it did work. Okay. All right, so what we're doing here is find r of t, and they're giving you these three pieces of information. So to get to r of t, we're going to have to integrate all double prime of t to get r prime of t, and then integrate r prime of t to get r of t. So we integrate our r double prime of t, which we're given. So that becomes the integral of 0 dti plus I did, and I left the negative over here, integral of negative 4 cosine t dtj. So when you integrate this, you'll get 0t plus c1i. Over here, you'll get negative 4 sine t plus c2j, which will give you c1 comma negative 4 sine t plus c2, because that's just 0 plus c1. Then they gave us an initial condition. They said r prime of 0 is 0, 0. So this is r prime of, so it says that if I replace t by 0, I get 0, 0, which makes c1 equal to 0 and negative 4 sine 0 plus c2 equal to 0. Well, this whole thing is 0, so c2 has to be 0. So we now know that c1 is 0 and c2 is 0, so we now know that r prime of t is c1, which is 0, minus 4 sine t plus c2, which is 0. Here it is in ij form. Now I'm going to integrate again. Integrate 0 dt times I. Integrate that. I'll get yet another constant, c3 times I, plus 4 cosine t plus c4 times j. So it's, if in component form, it would look like this, but they said that r of 0, oh, sorry, r of 0 is 0, 4. So if I replace the t by 0, I get to replace the left side by 0, 4, and then you'll end up with c3 is 0 and c4 is also 0, as it turns out. So r of t is 0, comma 4 cosine t plus 0, so it's 0, comma 4 cosine t, which they might write in